Proxy to the rescue, managing complex configuration variables. I'm Sar, I'm a DevOps engineer in open learning at MIT. The mission statement of open learning is to transform teaching and learning at MIT and around the globe through the innovative use of digital technologies. That's quite a tall order, and we are a department of around 150 employees. The department is still growing. It has grown quite a bit. I joined the team around 3 years ago, and I think we almost doubled in size so far. In fact, there's so much going on there that we have twice a year, we have poster presentations for the different departments or teams within open learning, just to kind of keep everyone on the same page and share some of the stuff that everyone's doing. And as a side note, this picture is not the building where I work. It is a building on campus. It's for computer science, but I love the architecture, and every chance I get, I try to share pictures of that building. So I'm on the engineering team, and the work that we mostly do is here. So if we start off with OpenCourseWare started, I think, more than 15 years ago, and it was a way at the time for faculty to just post their course material online for free for anyone to use. We on the engineering team, we are in charge of the infrastructure. We don't really deal with the course content creation or curation. There's a separate team under open learning that deals with that. Next up, the MITx, or internally we call residential. This is the platform used by MIT students for their online courses. It is all based on OpenEdX, the platform by edX. We use a lot of Salt to orchestrate and manage those instances. MicroMasters is a program that was started about 3 years ago, if maybe a bit more. And it's a way for anyone on the planet to take graduate level classes the first year, and then if they pass those, they can apply to finish up their second year at MIT or any other affiliated school. Boot camps they are boot camps that happen all over the globe. It's a team within open learning that does those, and they're different topics. Our team was responsible for just developing the basic web app for sign up and registration. MIT Open is something that's very heavily developed right now. The team's working quite a bit on it, and it's a way to connect or have discussions from around the world with MIT around different, mostly scientific topics. It's almost like the Reddit, but the MIT version of it. Again, it's still very active, and there's a lot more coming as far as I know. XPro is the last thing we worked on, and it's professional development. So companies contract a team within open learning to develop content for their employee training. And this, again, is built off of the OpenEdX platform. Now, why do you care about all this? Well, partly it's to promote some of the stuff we're working on, but the main part is to talk about some of those web applications and how we're dealing with the configurations of those web applications. So if you take a look at the last four, the MicroMasters, Bootcamps, Open, and XPro, they are all web applications, and they have different components, but the main bit is they are web applications that live in Heroku. Just a quick show of hands, does everyone know what Heroku is? Okay, so about half the room. So for the other half, Heroku is a Salesforce company. They were bought by Salesforce in 2010, I think. And it's basically a platform as a service, container as a service. It's just a way to deploy and manage and scale applications. And as you all know, web applications have configuration variables. This is just a screenshot of one of the sample application that lives in Heroku. It's their console, and it's basically some keys and values. So for example, if your web application has a need to use an AWS S3 bucket for storing whatever file, whether it's user profile images or some file that they use, you'll kind of set those configuration variables either through the console, or Heroku provides you a CLI. Any guess if one of those AWS keys expires, what might potentially happen? Exactly. Something breaks. Whatever feature that's using, in this case, an S3 bucket is not going to work. So just a little side story. I had just gotten into work. It was about a year and a half into me starting the job, so I'm not as nervous, as edgy when you see an alert coming through, because you sort of have an idea of where everything is. You kind of are familiar with some of the alerts and how everything is configured. And I see an alert coming in about some AWS invalid keys or invalid credentials. And as soon as I start looking at it, there's another Slack notification about a user who was trying to upload. It's an internal user in Open Learning who was trying to upload some images to a new class they're launching tomorrow, and as usual, it should have happened yesterday. It's high alert. Everyone's freaking out because the announcement's going out. They need to update this stuff. So I go in, generate new credentials, go through the UI, update the credentials, and I'm almost set to go. Try to get ready to go get my coffee since it just started the morning and I haven't really had a chance to do anything yet. And then I get another notification from one of our developers. So in Heroku, we have our apps in a pipeline. So we have the CI, we have QA, and we have production. They were working on the RC app or QA app, and it also stopped working because of some other invalid credential. Have to go in, again, generate new credentials, go in, update it just again and again. And I had to go in and do the same thing for CI because apparently we generated the credentials all at the same time, so all of them expired at the same time. And we have about 4 or 5 applications, I think, in Heroku, times 12 for CI QA. So I ended up spending maybe an hour just to kind of copy paste, generate, and I mixed things up too. And while I'm doing this, so I had to go in and repeat some stuff. So 2 hours later, I finally got my coffee. The day was over. I'm sitting at my desk though, and I'm thinking, there has to be a better way. Like, I will not do this again and again every month. We cannot just have a calendar reminder every month and we have to go in and do this manually. So what's the problem? If we take a look at the architecture, it's fairly simple. Most of our applications live, actually their EC2 instances living in AWS with our Salt master in there, and we manage all those EC2 instances, whether it's orchestration and configuration management through Salt. We rely quite heavily on it. And in case you're wondering, at MIT, a lot of the departments operate fairly independently. So while our central IT might have their own data center and we can make use of that, we operate almost like a startup, and that's one thing that was very attractive to me about the job is you operate as a startup, but you have the stability of an institution. And I think a lot of higher education institutions are set up that way. So if you haven't had the experience, I highly recommend checking out some higher education places. But to go back to this, so we have our SaltStack, the master sitting in AWS. We use HashiCorp Vault for secrets management, and all our pillar and states are in GitHub. And for all of you, everything I'll be talking about today, it's all open source, and I'll have the slide at the end for links to that, so you don't really need to worry about that. So everything lives in GitHub. The problem we were running into is some of those web applications that I mentioned previously, they're living in Heroku now. Heroku, under the hood, they all run their stuff in AWS, but to us, it's an outside environment. We have no access to that, and we need to manage those configuration variables. Since we use everything in Salt, we wanted to figure out some way of doing that through Salt as opposed to adding something else to our infrastructure. And the answer came by talking about Salt Proxy. So my coworker has been using SaltStack for a while, and he mentioned Salt Proxy. I had no idea what that was. I didn't even know it even existed. So I start looking around Salt's documentation, and the first thing that I saw was this image. This is from SaltStack documentation. Not to bash SaltStack, but I think the one thing they do a bit of a disservice to the proxy is, to me, the first thing that I thought about when I saw this was, I can manage network switches and routers and that kind of, those type of devices. I just don't see how that's going to fit with managing configuration variables in Heroku. It just did not make any sense to me. So I read documentation, reread it, sat down again with my coworker Tobias, talked about, this doesn't make sense. Am I misunderstanding that we can use Salt Proxy? And finally I realized that actually Salt Proxy can be used for a lot of things. It's a way, if you have no way of installing or don't want to install the minion, you can use a Salt Proxy. It's basically a process that's seen by the Salt master as a minion. And there are two types of Salt Proxy minions. There's the REST-based one and the SSH-based one. And I think that's where some of the documentation might be a bit misleading, because the focus is mostly on SSH-based stuff and less on REST-based stuff. So today we'll be focused on the REST-based one. So we wrote a module, our own module, to manage those configuration variables. And then the way it works is we have processes. It's a one-to-one match. So one process to one application in Heroku. They are running on the Salt Proxy master. On the Salt master. You don't have to run them on the master. You can run them on any minion. We chose to run them on the master, but again, you can do whatever you want. You can run them whatever you want. And all it basically does is it just makes HTTPS calls using the Heroku API to manage those configuration variables. So if we take a bit of a closer look at how this looks like. So when we run this command, now this is the proxy minion. You don't have to call it that way. Proxy, we just prefixed it with proxy just to kind of keep things nice and clean on our end. And just a word of caution on some of this naming convention stuff. And this applies to the minion, whether it's the proxy minion or anything you actually use in Salt, is just try and standardize on some of the naming stuff, because it can get out of hand very quickly. And I'll show you an example at the end of one thing we really ran into problems with, especially around pillar and kind of trying to templatize some of this stuff. So the Heroku.update Heroku config, the Heroku is the module we wrote, and update Heroku config is just the name of the state. So what happens when you run that? Well, since all our stuff lives in GitHub, this is a snippet of the pillar. Don't pay too much attention for the Vault bit. This is another module that we developed to work a bit more closely with Vault. But what this basically does is just eventually makes a call to Vault to populate those keys that live in Vault. So once this is in Vault, you have the access key, the secret key live there. Once all that gets to the Salt master, it renders all this stuff, and then the pillar takes this as just basic data and makes a call to the Heroku API and updates the configuration. So before anyone starts walking out the room, let's just rephrase what we're trying to do. So we have a REST-based Salt proxy applying pillar data that resides in GitHub and Vault to control Heroku configuration variables for a web application. This might sound very specific to some of you, because some of you might not even use GitHub for their states or pillar. They might not use Vault. You more than likely might not even use Heroku. But just keep in mind, GitHub and Vault are just use cases in our instance. You can have everything living on your Salt master. This is kind of just a use case, or you can be using something other than Vault for your secrets management. So it's not tied to that. So we take that out of the equation. Heroku is just a API from our standpoint, so you can have your applications living in some other platform somewhere else. You need to manage them some other way. So we can also take out that as part of the equation, and this becomes REST-based Salt Proxy applying pillar data to control configuration variables for a web application. So the gist of it is you can create Salt proxies, and if you have to, write some modules to manage whatever configuration variables for whatever web application that you need to manage. So before I go into the road ahead, let's just take a brief look. I'm not going to delve too much into the code, but let's just take a brief look at the Heroku module that we wrote. So the main bit in here is this function, the query function. This kind of sets up the call to Heroku and the proper endpoint to call Heroku, along with the API key that's stored in Pillar. And again, this is the API URL. And then everything after that basically use that function, the query function. So those are some of the functions I wrote. This is what the Heroku API provides. There's a lot more that you can do. I just wrote some stuff that I thought we might make use of. As an example, we have add app collaborators. So in case you have a new project coming up, a new web application in Heroku, and you want to add a bunch of users, you're not going to go, you can go in and do it manually one by one through the UI, but this you can at least pass some pillar, run the state, and then you're kind of good to go. It makes the call for you. And if we take a quick look at the Heroku state, the one that actually runs the update configuration variables, this is a tiny bit involved, and again, this is all code. It's all open source, so you can take a closer look later on. But the biggest thing to keep in mind is this is all it's doing is it's comparing two dictionaries. You have your pillar data as one dictionary, and then you have your Heroku configuration variables as another dictionary. Now, for a brand new app where you have nothing in Heroku, it's a blank app, that's simple because all you're doing is just copying your pillar data and filling up the configuration variables. It gets a bit more complicated in instances where you have an existing app and you want to update this stuff. So as an example we ran into was we had XPro is one of the apps that I mentioned before, and we had built this app before we even built this module. So the one thing we ran into, and I mentioned a bit about the naming convention. So we have in Heroku CI RC or CI QA and production. Some of the apps just have CI RC, but they don't have production. So Pillar gets all confused, and we have to kind of create some separate states for that, or at least define some of those. So yeah, this is a lot of the stuff. The other confusing thing, or the challenge when you're comparing two dictionaries, is Heroku gives you the way of adding add-ons to the app itself. So say that you want to add a database. If you add it in Heroku, it automatically adds a key and a value in the configuration variables. Well, the problem is you don't want to override that when you run your salt state. So when you're comparing the two dictionaries, you have to be aware that there's more keys in here than what you have in Pillar and not overwrite anything. We do have a state if you decide to just blow the app, all the app configurations, and just write everything from Pillar. We created a state for that. But again, the trickiest thing has been comparing the two dictionaries. So if we take a look at, this is the tiniest Flask application you can think of. So if we look right now, we have this Heroku app. I call it SaltConf. It has, it has no configuration variables, no keys and values set, and it just states that, again, this is a very basic Flask application to demo this thing. This is the pillar that we want to add to this app. Nothing too special for it. You have to decide the proxy type. In our case, we labeled it as Heroku. The app name, this needs to match what you actually have running in Heroku. So the app is called SaltConf. The API key lives in Vault. I think this is worth a separate presentation because some of the stuff we did, mostly my coworker did with Vault, is really cool and it's definitely worth something. But again, the code is online. And this just adds 4 or 5 configuration variables: a key, AWS random key, an access key, a bucket name, and then just a key and its value. So if we go in here, now first thing is we can check if the proxy, like I said, the proxy minion is just a process running on the master, and this is a test environment. There's a master running and I have the process running. It's a process running on the master, and if you look at it, you actually do have grains. It just looks like a minion. The one big difference from it and any other minion is some of the values are set to proxy, and this is what it looks like when you install it. Because from my understanding that Salt needs those keys and values, so they have to set something in here, and that's why it's set to proxy. But everything else, basically it looks like any other minion you see in your environment. And so what happens when we finally run our Heroku? So this is running the state. We saw the website. Website had no configuration variables. The state looked like it ran successfully. Let's refresh this. The keys and values are in place, and then if we take a look at the app is updated and it actually it's reading the keys and values. So we're good with that. If we switch back here. So what are some of the things we'd like to add to it? Right now we have it running on a schedule, so every 5 days it runs and updates pillar in those applications. We do have, so our AWS credentials or any credentials coming from Vault, we have them set to 30 days. So we have this running every 5 days just in case. And that's when it reads the new pillar and populates the new keys if they need to be changed. The only thing we don't have is we don't have any notifications or any alerting set up on any of this stuff. So that's one thing we'd like to have, at least when it runs or doesn't run, for us to know that it's actually running on schedule. The other thing I did notice was when I was preparing for this was there's a better way of managing the proxy service, and it's using beacons, so that's another thing I'd like to look at after this. I'd also like to add some abstraction to it. Right now, as you saw, the Heroku API was hard-coded in the code. I don't think that's good practice, even though it's specifically for Heroku. It would be nice to abstract some of that stuff, and maybe someone else could make use of it for other applications that they might need to manage. I'm not a developer, and if you look at the code, I'm sure it's going to be obvious. I have no tests, even though I have a computer science degree. That was the first thing they taught us in college, was write tests, write documentation, do all that stuff. I did not follow any of this, unfortunately, so that's definitely something I'm going to do really soon. And the last thing I'd like to do is probably upstream it. Right now, again, the code is there, you can use it, but I think it would be easier for everyone if this was available in Salt instead of you having to manage it on your own. So yeah, those are the big things coming up. Those are the repos. The GitHub repo is MIT ODL. We used to be Office of Digital Learning before they rebranded, and it's Open Learning now. So the repo is under MIT ODL. We do have the Salt Ops one, is where all our pillar and salt states live. The Vault and the Heroku stuff lives under the Salt extensions, and we have a lot of formulas too. So if you go to the main repo and just search for formulas, we have a ton of formulas there that we forked and maybe tweaked a bit for our use cases. The last thing I had to mention was, so the coworker I mentioned that taught me or told me about Salt Proxy is Tobias. He has a couple of really good podcasts in case you're not familiar. The first one is about Python and the other one focuses on data engineering. So I thought I'd just give him some promotion. And you can find me on GitHub at my first initial last name and then also on LinkedIn. And with that, any questions?
With the proxy minions, can you give us any idea of what fun troubles you may run into to get it going? So a little bit of my background, we're running the Salt Proxy Minions to help manage our Juniper SVX environment. And I've run into like different load issues. So I was wondering, what you've run into for fun.
Honestly, we have, I'm counting, I think we have 12 minions running on the master right now. So as far as load, there isn't a whole lot going on. The one thing, the biggest problem has been, and I don't know if it's me not understanding documentation, but when I first started writing the module, I got the impression that you need to run a Flask app, and then that somehow talks to the master, and that in turn talks to Heroku, and so I spent a bunch of time writing that until I realized that I was completely off track and had to go back. So most of the problems I ran into was just getting everything set up and writing the module. As far as the minions themselves, so far we haven't really seen any problems, but like I said, we only have 12, so it's not a huge use case.
Yeah, about picking Salt Proxy over other options. I mean, basically the use case can be met by just running a normal minion and running the modules from there. You can create a Salt runner to do the same things, and there's Salt Proxy, and there's probably two other that I'm not aware of. Is there any specific benefit that you see with the Salt proxies, let's say, compared to having a Salt runner that talks to that API? Or is it just, you went down this route, it went well, so that you're sticking to it?
I think what we wanted to do was to have those running as a service with a schedule, and we can monitor the service and add alerting and stuff. I'm sure you can do the same stuff with the runner, I'd imagine. But yeah, we started off with the Salt proxy, and that kind of got us on that deep end, and we just felt like that's a good way of doing it. Because the other way you can do it, you can easily, like I said, Heroku has an API, a CLI, so we can also call a CLI to run those commands. Just the proxy felt like a cleaner way of doing things.
Any other questions for Sar?
Cool. Well, thanks a lot.
Thanks, everyone.